All right, y'all, let's get down with these. Let's get down. All right, we're going to go ahead and simplify now these radical expressions here. And now we have these fractions guys here. So let's just go ahead and break these down. And let's get this. Okay, so let's remember that if you take the square root of a fraction, then that means we can take the square root of the numerator and the square root of the denominator. So we can break that up into the square root of 100 over the square root of 81. Okay, so we can take the square root of both of them. So the square root of 100 is 10, and the square root of 81 is 9. Okay, so really this middle step isn't all that necessary, but just to let you know where the 10 and the 9 comes from, I'm taking the square root of both the numerator and the denominator, and there's that answer right there. Now this is square root of 11 over square root of 25. Now we don't have a nice way of taking the square root of 11, so we have to leave it as radical 11. However, we can take the square root of 25, which is 5. Okay, and we're going to leave it just like that there. The cube root of 18 divided by the cube root of 125. So there is no cube root of 18, so we leave the numerator as the cube root of 18. Okay, because we can't simplify that guy right there. However, the cube root of 125 is going to give us 5. So we're able to simplify the denominator, but the numerator we have to leave it as we see it. Okay, so check this out. This is pretty rad right here. All right, so we know that this means the square root of y to the power of 8. And this means the square root of 16. So check this. See how this is y to the power of 8? Well, if this number right here, since it's even, we could just divide this by 2 and then just say that's y to the power of 4. If you're like, what? What the heck? Why didn't I do that? All right, here, well, let me show you how I know how to do that. Watch this. We learned back in the days that we can turn a radical into a fractional exponent, right? Meaning, isn't this right here the same as y to the power of 8 to the power of 1/2, right? This is the same as that. And then look, if I multiply 8 times 1/2, which that's one of our rules of exponents, that's going to be 8 over 2. And 8 over 2 is just y to the 4. So a cool way of doing this is the following: is really this number, our exponent 8, you just divide it by whatever our radicand is right here. So 8 divided by 2 is 4. But here's the work and the logic why it is 4 though. And then over here, square root of 16 is quattro. Cool. So there's that answer right there. And let's check this guy out. Okay, so this is a negative third root of x squared over r to the power 12. Okay, so this means I'm going to put negative, but then I'm going to put on the top the cube root of x squared, and the bottom has the cube root of r to the 12. And like I'll show every step here, so we're not missing anything. Okay, and I'm just going to keep this negative on the outside, and then at the end we're going to have a negative there. Okay, so let's see. How do we simplify this right here? Well, again, this is the same thing as saying x to the power of 2, raise that all to the power of 1 over 3, right? Okay, say yes. Yes, of course. All right. And this right here means r to the power of 12 and raise that all to the power of 1 over 3. Okay, so I'm just going back and using this logic here and what we used a couple of sections ago. Now check this out. I can simplify the numerator by just multiplying 2 times 1/3. Meaning if I want to put a 1 underneath that 2 times 1 and 1 times 3. That's negative x to the 2/3. All over. Now 12 times 1/3, that's 12 divided by 3. And so that's going to be r to the 4th. So our final answer would be this guy right here, negative x to the power of 2/3 all over r to the power of 4. And if you wanted, or like another rendition of this, you could write this as a radical, right? I mean, you could rewrite this as the third root, negative third root of x squared all over r to the power of 4. Okay, so for example, if the direction said write your answer in radical form, meaning that you have radicals, you want to do something like this. If it said only write it with only exponents, then you would write like this. So we just got to be able to go back and forth and understand that these things are equivalents, and they're the exact same thing there.